since I know everyone in here is ready to go, let's see. So, class.
Yes.
Thank you. All right, so pretending like you want to be here is probably the greatest joy of my life. Okay, just everyone should be doing that. All right, derivative, cosine. We talked about the derivative of circle, and yesterday we actually talked about the cosine, so that goes along with all of it. Now, this one right here, so we're going to go through and do item by item. Now, what rule is A going to be? There's a rule to go along with it. Here, let me help you cheat. What's happening right there? Multiplication. So if there's multiplication happening between the x squared and the cosine x, what is another word for multiplication? Starts with a P, ends in adduct. Yes, product rule. Very good. So product rule. So we're going to do a product rule. So I have f of x equals x squared times cosine. So f is x squared, f prime is 2x, g is cosine x g prime. What's the derivative of cosine? Christian?
Negative sin x.
Negative sin x, very good. Alright, so my product rule goes as such: f prime g plus g prime f. So f prime is going to give me 2x times g, which is cosine x plus g prime, negative sine x times f, which is x squared. Alright, and clean it up a little bit. So I should get 2x cosine x, and this is going to be minus x squared sine of x. ¿Está muy fácil? Es muy fácil. Now, for those people taking notes at home, you notice every single time I keep writing my f prime, g prime, I state what it is. Every single time I state it. Don't do any shortcuts. When you do those shortcuts and you don't write stuff out, that's where mistakes are made. The little mistakes. Trust me, I've been doing it for a lot of times and I make a lot of mistakes. So, show as much work as possible. Alright, so let's go back to this, and so B, it is g of theta is cosine theta over 1 minus sine theta. So what rule is this one going to be? What rule is this? What's happening in this problem? A what? A division. What's another word for division? Quotient, right? It's that easy. So you don't shrug you're like, okay, what's happening there? There's a division, so therefore it's a quotient rule. So I'm going to use that. So let's go that. So g of theta cosine over 1 minus sine. again, every single time. So f is cosine theta, f prime is negative sine theta, g is 1 minus sine theta, g prime is, what's the derivative of negative sine? Negative cosine, right? So you could just go to your wheel, go to the circle, find your whatever it is, and then use that. And derivative 1, that just goes away, right? So I have negative cosine theta. Alright, so my quotient rule, which I'll write out here, so f prime g minus g prime f over g squared. And go through there. So I get negative sine theta times g, which is 1 minus sine theta, minus g prime, which is cosine theta, plus sign, because it's a negative and I have a minus sign there, and then times f, which is cosine theta. There we go. Do a little bit of distribution here. Just a little bit. Just a little bit. A little bit of distribution. So right here I have sine theta, so I get a negative sine theta times the 1, and then plus sine squared theta plus cosine squared theta. Can anyone tell me what's the one thing I could do with this? Go ahead. What is the one thing?
Last two terms equal 1.
Yes, sine squared plus cosine squared is always 1. So whenever we have trigonometry and you see those together, okay, that's one thing you could do. Replace it with 1. So sine squared plus cosine squared is going to give me 1. So my answer to all this, because that equals 1, is going to be 1 minus sine theta. You could put negative sine theta plus 1 if you want to, but that's same thing. Do you guys remember those identities or no?
I remember that one.
You remember that one?
Yeah, I remember them somewhat.
Okay, so that's a good place to start. Let's go through and list all our identities starting out, and I'll show you how to make new identities. We know that sine squared plus cosine squared equals 1. So I'm leaving off my thetas just for the sake of, so you could actually pay attention to this. Now, let's pretend I know my unit circle. So this is in a huge land of make-believe, right? That I know my unit circle. Let's call this one pi over 4. My answer is going to be square root of 2 over 2, comma, square root of 2 over 2. Yeah? This first square root of 2 over 2, what does that represent? That's my cosine value, right? So we have a cosine value And the second one is my sine value. But in the sense of coordinates, that cosine is just my x value and y value, right? Now, this is one of those calculus identities that come up later. It's called a U-sub. So, but I'm going to use it for all trigonometry, and that's going to make your life a whole lot easier. Because by using substitution, I could turn everything in calculus, or I'm sorry, in trigonometry, into an algebra problem. And I'll show you how. This is going to turn into y squared, right? And in my circle, it's actually a triangle here, right? I have my y value here, my x value here, and my r in these circles, which are identities, has a radius of 1, right? Because over here, the coordinate right here is 1, 0, isn't it? So my radius is 1. So it's not really just the y value, it's sine, which is opposite over hypotenuse, right? So it's going to be y over r, my radius, or y over 1. So using that information, I could just say it's y over 1. But what is y squared divided by 1? Just y squared, isn't it? Okay, let's just keep going. Cosine is my x squared over 1, right? Okay, and that's equal to 1. But isn't that just 1 over 1 squared? Because I gotta try and figure out, where did this really come from in the first place? This whole thing came from my Pythagorean theorem, which is a squared plus b squared equals c squared. In which that my c is this piece right here. That's my c. I have my x, which is that one right there, and I have my y, which is that one right there. A, B, C. That's the parts of a right triangle. And all my identities are based on that. They're all based on that. Am I losing anyone here? Okay. So I'm gonna blow your mind on a whole bunch of stuff here. If this is the Pythagorean theorem, and this is my Pythagorean identity, which is x squared plus y squared is equal to 1, that's where those come from. In my circle, it's going to be equal to this. That's why I get my x squared plus y squared is equal to whatever my r value is here. Okay? So keep going here. So if I have y squared plus x squared equals 1, I'm going to do something crazy. I'm going to divide everything by y squared. If I divide everything, both sides of the equation, by y squared, is it still going to be equal? If I multiply both sides of the equation by 5, would that both sides still be equal? Yes, they would. They're still equal. Here, I'll do a little math for you. So 2x plus 5 is equal to, let's say, 11. Okay? So I can do the math, subtract, that's going to be, what's that going to be? I'm going to have 6, and then divide by that, x equals 3, right? So, multiply everything by 4. Common factors. So 8x plus 20 equals 44. Subtract 20 to both sides. Okay. And then I get divided by 8. I still get x equals 3, right? So that makes sense right there, right? So basic algebra right there. That should make sense. So now what I'm going to do is, instead of using numbers, this is still going to work for what we're doing here. I'm going to divide everything by y squared. What is y squared divided by y squared? 1. Let's translate this back into trigonometry. Right now, it's just algebra. Let's translate it back to trigonometry. If we know that x represents my cosine and my y represents my sine, this is going to turn into 1 plus cosine squared over sine squared is equal to 1 over sine squared. What is cosine over sine? Cotangent. 1 plus cotangent, because they're both squared, it's going to be cotangent squared is equal to, what is 1 over sine? That's the reciprocal of sine, right? So that's going to turn into cosecant squared. So by translating this over to algebra, did I make a second one of my identities? Yeah. There's a bunch of these too. And so to get another identity, what can I do instead of divided by y squared? Divide both sides by x squared. So I'm going to take my information. I have x squared plus y squared equals 1. Divide everything by x squared. I get 1 plus y squared over x squared is equal to 1 over x squared. Translate this back to trigonometry. 1 plus, remember y is the sine value, right? X is the cosine. Sine over cosine is going to be tangent. Sine over cosine is tangent. So since they're both squared, that is tangent squared equals, now what is 1 over x? That's the reciprocal of cosine, isn't it? So if x is cosine, 1 over x is the reciprocal, which is secant. So this is going to turn into secant squared. Remember when I said I don't memorize all these, I make these every time? There's so many of these that you are going to use so often that you're just going to like, boom. But I could use this information to actually make other ones. I'm going to rearrange this now. I'm going to subtract 1 from both sides. If I subtract 1 from both sides, what do I get? Minus 1, minus 1. I get tangent squared is equal to secant squared minus 1. So, by using substitution, I could actually substitute and replace a tangent squared with 1 minus, or c squared minus 1. Secant squared minus 1 in a lot of my problems. And this is actually what you're going to have to do. You're going to have to identify these and be like, yo, I need help with this. Okay? And be like, oh, hey, look, I could turn it into this, which would make my math problem work out a lot better. So is that craziness or no? Did you write that down? So I'm hoping you actually got something out of this. Thank you, my dudes. Is it like a re-image thing or something?
We'll see. We have another company right now using our stuff, so it might be.
Okay, alright, thank you. Are we okay now? Yes? Okay, alright, so I'm gonna go back and I think I still had to do part C, don't I? So, E of t divided by cosine t. Juju Bear, you ready? What type of problem is this asking for?
Quotient.
Very good, quotient. So E of t or cosine. Yep. There you go. Start listing it out. My F is E of t. F prime is E of t. My G is cosine t. G prime is going to be negative sine of t. List out my quotient rule. So I have F prime G minus G prime F over G squared. F prime is E to the T times G, which is cosine T minus sine, negative sine of T, times F, which is E to the T, and clean it up a little bit. So it's going to be E to the T cosine of T plus E to the T sine of T. Are we happy with that? I forgot to divide. Thank you. See? Seeing if you guys are actually finally paying attention. So that's going to be G squared. Just wondering if everyone's asleep and just nodding their head every time I say, hey, is everyone okay? So. Are we good? Questions, concerns, complaints, conspiracy theories? No conspiracy theories either? Find all points on the graph f of x equals x plus sine x where the tangent line is horizontal. Okay, a couple things are important here. Tangent. So when you see tangent, what should you think of? My first derivative, right? The tangent has to do with the slope of my first derivative. That's good. Okay, and a horizontal line. What do I know about the slope of a horizontal line? It's going to be 0. The slope of the horizontal line is going to be 0. So this m equals 0. Okay, so that's a good thing to start off with. So we have our goal, our direction. So I need to take that function, have the derivative, and the derivative be set equal to 0. So, let's see. So f prime of x is equal to, derivative x is just going to be 1. Derivative of sine x is cosine. x. So there's my derivative. And I want my slope to be equal to 0. So that means my derivative, this right here, should mean that my derivative has to be equal to 0. That's a 0. So I'm going to take my derivative and set it equal to 0 and see what I get. 0 equals 1 plus cosine x. Subtract 1 to both sides. I get -1 equals cosine x. Now, there's two ways of looking at this. One way is you totally understand your unit circle and you're like, dude, I got this, I don't need any help, I'm good. I know my unit circle by heart. So I could think, where is cosine equal to -1? At pi, isn't it? Okay. So I already know that right there. But mathematically, I'm gonna need to actually do a little bit more complicated problems on this. So I need to actually get x by itself. Anyone recall, how would I get the x out of the cosine x? Say what? Inverse, right? Inverse or arc, right? So it's actually written both ways. So arc cosine or inverse cosine for both. And when I do that, it actually changes this. So it's going to move where the x is located at. So it's going to move these, and it's going to say x is equal to arc cosine of -1. Because every once in a while, you're going to have multiple steps on this, and sometimes they're not. Usually, they're not just right there on the unit circle, so simple. You're going to have to do a little bit of math to actually make it happen. So x equals that. So that means, where is x? That's going to be x's at pi. So every iteration of pi, because cosine is a wave. It keeps going over and over again. And so every place that is actually going to have a slope of 0 is going to be at pi. So that means that in my normal interval would start like this. 0 to pi close. This is what you normally see on an interval. My bracket means that I can include 0, right? So I can include 0 and goes the 2 pi. Okay? So in between there, I only have one location, right? In between that interval, I only have one location for it to happen. It's not happening at 0. It's happening at pi. So when is the next one going to happen? Where? 3 pi. Okay, so it's going to be 3 pi. And the next iteration of it is going to be at 5 pi. So if you think about it, in the pattern, if I start at pi, next one's going to be 3 pi, then 5 pi. So I could actually do what? So it's going to be every iteration of that. So let's see. Now I need to find an equation to actually make it happen. You're saying pi plus 2 pi like that. So for every iteration I have, so on my very first one, it's going to be 0, right? It should be 0. How would I make that into 0 though? Because if I want my first one, I'm not going to be, wouldn't that just be n minus 1? because when you're counting in your terminology, and I want my first one, because if I say, all right, what's gonna be the first time, starting in my interval, I would start at 0 and moving to the positive numbers, my first one's gonna be at pi, isn't it? So if I want it to be at pi, this has to be 0 over here for that to work. Otherwise, if I plug in 1, wouldn't my first iteration of that be at 3 pi? Are you understanding the pattern, Christian? You're giving me that crazy look again.
Each iteration just by every occurrence modifications to the x-axis every.
Yeah, we're just going the positive. We're just going positive, starting at 0, and for every place. So now, if I were to go in the other direction, if I were to go in the negative direction, it'd be -1, right? Okay. So I started with 0, and then -1. Okay, so then we go that way, right? So as we go the other direction, it would start at 0, or I'm sorry, start at pi, and then it would be -3 pi, right? So you can count it in both directions using this.
What does that n signify?
How many iterations you're gonna do. So since this is gonna be endless, so if I wanna say, hey, what is the 4th time, where's the location that this is the 4th time that it comes up to be 0? Okay, the 4th time it comes up to 0, I plug in 4, -1 is 3, so that's 6 pi, plus that's 7 pi. So my 4th term is gonna be 7 pi. That's what that refers to. Make sense? Okay. Alright, so I'm gonna leave off here for today. I want you guys to actually start working on some of this. And how many more do we got? We don't got very much more, do we? Yep. Just a couple more. Alright, so I'm hoping that we will finish this up on tomorrow. Tomorrow's Thursday, so your homework should be due Monday.